Today's section is about solving special types of linear systems. So the things that we're doing in this section aren't actually very new. There's a few new terms that we're going to have, but for the most part, there's nothing new here. So I actually would like you to attempt to solve numbers 1 and 2. For number 1, use elimination. For number 2, use substitution. Note that you will get a weird answer, so go ahead and pause, give them a try. So I'm hoping that you got something strange for both problems, because if you did, you were doing it right. For number 1, I asked you to use elimination. So you would do that by eliminating either the x or the y, and I'm going to do that by multiplying one of the equations by -1. So now, on this next step, you might already be able to see that there is something weird going on. Because when you add straight down, you are going to get things canceling out. So what's going to happen, we know 2x minus 2x is going to cancel out. -3y plus 3y is going to cancel out. I'm going to bring down my equals. I know that the left side, it's not just going to be blank, because things actually, -2x plus 2x is 0, -3 plus 3 is 0, so actually I'm going to write 0. On the right-hand side, 6 plus 4 is 10. So you might notice we have something strange. This is a false statement. Now, if you remember, when we have a false statement, the answer is going to be no solution. And once again, as I said in a previous video, if you want to do it kind of the lazy way, you can write it just as a 0 with a line through it. We call that the empty set, but that's another fancy way to write no solution. So then number 2, I asked you to solve using substitution. You could have done this by elimination actually, and you could have done the previous one with substitution, but for this one I just told you the easiest way to do it. So what I'm going to do is I'm going to take this 2x minus 4, substitute it into the y in the other equation. When I do that, I end up getting 4x minus 2. My y now changes to 2x minus 4. I get that that equals 8. And when you work it out, you will find that the -2 times 2x gives you -4x. The -2 times -4 gives you +8. I'm hoping that you got something weird, otherwise you probably made a little mistake in there. And 4x minus 4x, you'll notice, is actually just going to be 0. These are going to cancel out. You can write the 0, but you don't need to. So I'm just going to write that it's 8 equals 8. So then this is a special type of linear system. It is not no solution. And actually we have a special name for it when we have a true statement. So when we have a true statement, that means that we have many possible things that we could have for x and y. In fact, we have an infinite number of things. So we are going to say when we have a true statement that we have infinitely many solutions. So now I have 2 more special systems of equations, and this time we're going to solve by graphing. I know that graphing is not the favorite way to solve it. However, I think it's important that you see what happens for our special systems when we graph them. So what we're going to do, remember that in order to solve by graphing, you need to graph 2 lines, you need to find where they intersect, and that's going to be your answer. At least in the past that was. Now it's going to be a little bit more tricky. So let's start by taking the first equation and we're going to graph that. Now I always like to graph by using slope-intercept form, y equals mx plus b. So I'm going to solve for y. I get y equals -x minus 1. That gives me a slope of -1. And I'm going to write that as a fraction, so it's negative 1 over 1. And it gives me a y-intercept of also negative 1. So what I'm going to do, I'm going to start my graph at the point negative 1. For my slope, it's negative 1 over 1, so that means I go down 1 and right 1 also. So I'm going to go down 1, right 1, draw my next point from there. So I recommend that since you guys are doing it on paper, use a ruler, use graph paper. Your line should look much nicer than mine. So then for the second one, we are going to graph this second equation. That one luckily is already solved for us. It has a slope of also negative 1 over 1. It has a y-intercept of 5. So what I'm going to do, I'm going to go up on my y-axis to 5. Once again, I'm going to go down 1, right 1. Then I am going to nicely draw a line through those points. Once again, ruler is highly recommended. And you might notice something weird. So, in general, we look to see where the two lines intersect. However, you will probably notice that these lines never intersect. They are parallel. They never, ever are going to touch. That will always happen for two lines with the same slope. They're going to be parallel. So, in this case, we're going to say that we have no solution because there is no intersection point. So that's what our no solution looks like. Now, our second type of graph is going to also be a special case. However, it's a different type of special case. So for this one, my first equation is pretty nice. It's already solved for y. I have a slope of positive 1 over 2. And I have a y-intercept of 2, so I'm going to go ahead, go up to 2 on my y-axis, go up 1, right 2, and then draw a line through those 2 points. Now I'm going to do the same thing with my other equation. Unfortunately, with the second one, I do have to do some work. I have to solve for y. I'm going to start by moving over my x. Since the x is positive, I would subtract it. It would become negative x minus 4. I'll actually write that step out so you know what it is. I like to put the x first, just because in slope-intercept form, the x comes first. Y equals mx plus b. The x always comes first. Next thing I'm going to do is divide everything by negative 2. So on the left-hand side, I am just left with y, which is good. I was trying to be left with y. Negative x over 2. So now there's a few things going on here. First of all, if you have a negative divided by a negative, it's always going to be a positive. So it's actually just going to be x over 2. The second thing is, if it makes it easier for you, you can add a 1 in front of that x. So actually you'll find that that is going to be 1/2 x right there. The second part of it, we have negative 4 over negative 2. That gives me plus 2. So then, if you're very observant, you might already see something really weird going on. So I find that my slope is 1/2. My y-intercept is 2. But if you look at the previous equation, the slope is 1/2, the y-intercept is 2. So actually, if you put it on that point there, if you put your y-intercept on 2, then you go up 1, right 2, you will find that you get the exact same line. So what you have here, in the previous one we had two lines that never intersect. In this one we have two lines that always intersect. So that means that they intersect at many little points, like there. You can even draw lots of little points on there if you want to show yourself that they are intersecting at zillions and zillions of points. They actually intersect at an infinite number of points. So once again, as in the previous example that we had, number 2, we are going to have infinitely many solutions. By the way, For numbers 3 and 4, you actually can solve these problems also by using either substitution or elimination. However, I did want you to see that by graphing, you will find that this is what happens. So, once again, just make sure that you know what the graph looks like. Luckily, on your test or quiz, I'm probably only going to give you one where you actually have to solve by graphing because it does take a long time. But you will have to be able to identify that the no solution, which is what we have in number 3, is 2 lines that are parallel. Infinitely many solutions is just 2 lines on top of each other. By the way, the stuff we did in section 6.1, all of those we had one solution. 1x, 1y was one solution.